This question was brought up by one of the members on the Telegram channel. This name here, I don't know you, man. I don't know how to pronounce your name. But the question is saying that 3 consecutive arithmetic progression terms have a sum of 36 and a product of this one here. Find the 3 terms. There is one concept I want us to understand. I can have a series which is like this. Yeah, 2 plus 4 plus, you can see this for this series an arithmetic progression, and when I consider, I can have the series 2 plus 4 plus 6 plus this series is the same as this one. The starting term A is 2 with the starting point 2. What I want to tell you is that I can take off this side. It will not be the same series, but I can also have 8 plus 10 plus 12 plus very many. That is removing this part and starting from here. When I do that, I have that the starting point, the first term, our A will be what? Will be 8. And we shall have different, if you are to get the sums, we shall be having different sums, because this one has started from 8, while this other one has started from 2. I can start a series from whatever point, and I can have a starting term A. So we have, if I have this term, this series, for example, these are 3, 1, 2, 3 consecutive, but the starting term is 12. So I can have 12 plus 14 plus 16. Those are 3 consecutive. And if this one is A, this is A plus D, this is A plus 2D. That is what I want you to know, is that a series can start from any point, and whatever point it starts, the first one will be A, and the other one will be A plus D, followed by A plus 2D. Let me clear this. So that means that our 3 terms, the first term is A, followed by A plus D, followed by A plus 2D. Those are the terms. These are the terms for which they are saying that the sum of these terms is 36. So we have that A plus D plus A plus 2D, first term, second term, third term. So it's when you add up all of those, when I add up, I get 36. This one can simplify to 3A plus 3D equal to 36, and can simplify further as A plus D equal to 12. Call that equation number 1. They said the product is 1428. So the product is this is A into A plus D into A plus 2D. When I open the brackets here, when I expand, I shall have A power 3 plus 3A squared D, followed by 2, that is 2AD squared. And when I add when I multiply all of that, they say the product should be 1428. Now if I use I can call this one from here to there, that equation I can call it equation number 2. And from equation 1, you can say that you can solve the 2 equations 1 and 2 simultaneously by using the method of substitution. I can substitute for A by having that A is equal to 12 minus D, but because I'm going to have A power 3, D minus 12 power 3, it may be somehow cumbersome. Not that it is not doable, but there is where we can just get D squared. So I don't need to have a term which has a power 3. So I shall say that from 1, I shall say that A, I'm going to substitute for D. D is equal to 12 minus A, and this one shall imply that A power 3 plus 3, this is A squared. Instead of D, I have 12 minus A, then plus this is 2A. Instead of this D squared, I have 12 minus A, everything is squared. And when I do that, I equate to that. When I open the brackets here, let me have this. I shall have this one is A power 3 plus this one is some bit of 36A squared minus 3A cubed plus, let me write this. This is 2A, and this is 144 minus this one is 24A plus A squared. That is expanding 12 minus A in squared. This is 1428. We shall open the brackets here by multiplying 2A by this chunk and then working out everything. We are going to come to the fact that A squared minus 24A plus 119 is equal to 0. The A cubed will cancel, and when you work out the A squared, you are going to get some negative 12, then multiply through by negative. You are going to have that. And from this, it is quadratic in A. I'll have two values for which the first value of A is equal to 17. Shall have one A which is 7 and an A which is equal to 17. And we have that for A equal to 7, from equation 1, shall have that D is equal to 12 minus 7, which is equal to 5, and the terms will be, the terms are, the first term there is 7, followed by A plus D, which is 12, then followed by another term, A plus 2D, which is 17. Then also for A equal to 17, D is equal to negative 5, because that one is 12 minus 17. And we have that the series now, the terms, the three terms which we are looking for. The first one is 17, followed by, remember now we have D minus 5. So 17 minus 5, that one is 12. 12 minus 5, that is 7. We are having the same numbers, more that one is in ascending, another is in descending order. So those are the terms which we have got. In case you have any problem, you can always comment and I can see your queries.